This video is going to go over some key ideas from section 1.2, which was transformations of functions. So ultimately what you need to be able to understand is all of the features of A, H, and K. So if we're talking about transformational form, I need you to know that A is the number that creates a vertical stretch or compression or a reflection over the x-axis. So ultimately, you really have three different situations here. So A is greater than 1. So A is a number like 2, 3, 1.5, anything like that. That's going to be a stretch. A stretch is going to make your graph more narrow vertically if we're talking about parabolas or absolute values. The other type of, or the second type of A is a fraction. So if I have a A that's a proper fraction, it's between 0 and 1. So numbers like 1/2, 2/3, smaller number on top, larger number in the denominator. That's a compression. Remember that a vertical compression makes it more wide when we're talking about the functions we've talked about. Okay, so it's pushing it down vertically as opposed to stretching it up vertically. And then the final one is when A is less than 0. Remember, this means that A is negative. That's going to reflect it across the x-axis for the point of our graphs that we're graphing absolute value and quadratics. It means it's going to point down. Okay, so the graph's not going to point up, it's going to point down. It's going to have a maximum instead of a minimum value. The next piece of a function that you need to be aware of is H. So H creates the horizontal translation. So when H, I wrote A again, when H is a positive number, that's going to move it to the right. The funny thing about H is that notice it's being subtracted here. And so what happens is that if I have something like, for example, x minus 2, that's going to move my graph to the right because that H value is positive. If H is negative, then that's going to move it to the left. And so again, that would look the opposite of that. That would be something like x plus 2 because minus negative 2 creates a positive 2 inside those parentheses. The way that I try to remember this is that that number inside parentheses, that's the one that I always change the sign. Okay, so when I'm identifying what direction it's going, it's the opposite of what appears in the function. K is what creates the vertical translation. So when K is positive, that's going to move up. When K is negative, that's going to move down. So K works intuitively. It's not the opposite the way that H is. So it's just if I have, so for example, I have my f of x plus 2, that's going to move me up. If I have my f of x minus 2, that's going to move the graph down. So then if we are solving problems, we want to think about that. So we're going to start with visuals. Okay, so for our first example, we're going to compare our parent function, which is the solid blue line, to the dotted green line and verbally describe those transformations and then translate that back to an equation. Okay, so the first thing that we need to notice is that our parent function for this is a parabola. And so that means that f of x is equal to x squared. So when we're writing our equation, we're going to use the x squared function to find our other pieces. So if I can just look at my graph and see what happened, it's good to start at the vertex. So the vertex was here at 0, 0 for our x squared function. Notice it moved to the left 3 units. Oops. And then it was originally pointing upward. Now it's pointing downward. And so that's that reflection over the x-axis. And so that creates that downward shape. Notice though that the pattern's still the same. So I go out 2, up 1 for both of them from my vertex. and then out 1, up 3. That pattern isn't changing. And so that means that I haven't had any kind of vertical stretch or shrink or compression. And so it only moved left 3 and was reflected over the x-axis. So remember that when it's reflected over the x-axis, all that that means is that A is negative. And so since there was also no stretch or shrink, what that tells us is that A is equal to -1. So the shape wasn't changed in terms of its stretch or compression, just its direction. And then the left 3 units is an H value. So what that's telling us is that H is equal to -3 because left is -3. Okay, so what this tells us is that this green function, which we'll call g of x, is equal to -x plus 3 squared. Okay, so if I look back at what I did, in the function, A is the first number in front being multiplied by our parentheses. So A was -1, that creates a negative. H is -3. I always change the sign when I place it into my equation. Next, we have the graph of an absolute value. And so I know that because it's the shape of a V. So my f of x for this graph, I know is the absolute value of x. So remember that with these, it starts at the origin and then the pattern is just up 1 over 1. Okay. So then let's look at what's going on. So our vertex for the green graph has moved upwards 3 units. Okay. So it's gone up 3 units. It's still facing the same direction, but notice that the pattern has changed. So when I go out 1, I'm only going up 1/2. Out 1, up 1/2. Out 1, up 1/2. So notice that my pattern has gotten squished downward. That's a compression. Okay, so that means that I have a vertical compression by 2. And so what these two things mean is that our value for K is +3 and our value for A is 1/2. Remember that the hint for A is how far we went up. So we went up 1/2 every time. Typically you go up 1. Okay, so that number matches your A value. And so what this means in terms of our equation is that g of x must be equal to 1/2 absolute value of x plus 3. Okay, so K is the one that's outside the function. So we do not have a value inside our absolute value because we didn't move left or right. Okay, so for our last one, we have another absolute value. And again, I know that because I see that it's the V shape. And so I want to figure out what are the transformations that got me from this 0, 0 point to the vertex of my new graph. And so notice that it moved to the left 3, but it also moved up 3. Okay, so our graph moved left 3 and then up 3. And then if we check out the pattern, it was up 1 over 1. Notice the pattern stays the same, but because it's pointing downward, we have a reflection over the x-axis. So just a reminder, so let's what each of those things mean. Left 3 tells us that h is equal to -3 because left is the negative direction. Up 3 tells us that K is equal to +3 because up is the positive direction. And then finally, a reflection over the x-axis, but no stretch or shrink, tells us that A is equal to -1. So it just changed the orientation, not the overall shape. Okay, so in terms of our final function, that means that g of x is equal to negative absolute value of x plus 3, because we changed the sign on h, plus k, which is +3. I almost wrote k there. Okay, so that's our equation for the last graph. Okay, so now we've seen a visual going to a verbal, and then writing the equation, right? So that's kind of the easiest way to go from the visual to the equation, is to write out and talk it out what the changes are visually. Another thing that you should be able to do is look at an equation and pull the verbal, right? And so what I'm doing each time is I'm comparing it to that AHK form. So I want to figure out what are each of these pieces so that I can just use them to describe my graph. Okay, so if I'm comparing f of x, which has a is 1, h is 0, k is 0, that's normal. Now I'm looking at negative 3x squared. So the number being multiplied is a. Then if I had something adding or subtracting inside the squared function, that would be my h. Whenever I don't have parentheses or an absolute value sign, something like that, inside, no number inside, then my h value is 0. And then my k is that last number, which is minus 1. So what we need to think about is what each one does. So what a does is two different things. Okay, so the negative creates a reflection across the x-axis. And then what the 3 does is a vertical stretch. And we always say that it's by a factor of that number. Since h is 0, we don't need to address that there is no left or right translation. We just say that k tells us it's translating down 1. So then for the last one, we've got an absolute value function. Still works the same. We need to figure out what ah and k are. So if we look at our function, the number in front is our a value. Our a here is 2. When a is a whole number like this again, that's the vertical stretch. So this just has a vertical stretch by a factor of 2. It doesn't have the reflection because it's positive. The number inside our parentheses is h. Remember, this is technically the opposite of h, so h is really negative 1. So when h is negative 1, that means that it's been translated to the left 1. And then finally, we can see that there's nothing being added on the outside. And so what that means is that k is 0. So this graph is not moving vertically. Okay, so from this video, you should see that we have to understand what a does, what h does, and what k does, each individually. And you need to be able to see it from a graph, describe it with words, and write it using an equation, or take an equation and write it with words. Okay, so it's important that you practice and understand what each of these letters do within the graph of any given function.